Okay, you're asked to use the rational root theorem to list all possible rational zeros. So that's exactly what I just finished doing on that example. But then you're asked to take that, go another step, and actually find the ones that are really the true rational roots. Okay, so that's kind of the new part that I'll have to explain here. Okay, so let's get our list. Let's do their P's and our Q's just like what we did a while ago. So P, remember P is always going to be associated with the constant term, which is the -10. So listing all the numbers that will go into 10, again positive and negative. Okay, and now Q. Q is going to be your leading coefficient. So if you find your largest exponent, the number in front, so that's going to be a 2. And list all the numbers that will go into 2. Okay, so now we're going to do P over Q. Okay, so just like a while ago, I take all of these numbers and I put them over 1. So 1 over 1, 2 over 1, 5 over 1, and 10 over 1. So that's just going to give me that list of integers back. And now I've got to put them all over 2. So 1 over 2 means I need to add a half here. And then 2 over 2 reduces to 1, and I already have it. 5 over 2. And then last is 10 over 2. Of course, 10 over 2 reduces to 5, and you already have it, okay? So that's the first half of the problem, getting the list. Now, when it says to find one of the actual rational roots, this actually goes back to what we learned in the first part of chapter 5. If you remember, you had those problems in which you did synthetic division. You were wanting to get a remainder of 0 each time. That's what you're looking for here, okay? So I'm wanting to know what numbers in this list can I plug in for X and it equals 0. Okay, now like I said, we did some stuff before with synthetic division and we wanted our remainder to be 0, which is the same thing as me substituting these in for X and finding out which ones make it equal 0. Okay, that just goes back to the remainder theorem. You can do that 2 different ways. Of course, I think it's just going to be easier and quicker just using your calculator. And I mean, you don't have to have any kind of fancy calculator to do this. You're just plugging in numbers. So let's just start out with the +1. So I'm starting with my list here, and I'm going to substitute +1 into the function. So that means I would have 2 times 1 to the 4th power minus 7 times 1 to the 3rd power plus 2 times 1 minus 10. And I had already figured that. That's going to give you -13. So obviously, +1 is not one of those. So I was going to exit out. I'm going to put an X by it because I need the ones that are going to cause this to equal 0. So then you just have to go down your list. Okay, so now we're going to check -1. So 2 times -1 to the 4th minus 7 times -1 to the 3rd plus 2 times -1 minus 10. So that's actually going to give me -3. That's not going to work. Okay, now I'm not going to take time to do every single number. I'm just going to tell you what's going to end up happening. If you plug in your +2, then you're going to get -30. Okay, so that's not 1. Then you're going to plug in the -2. If you plug in -2, you get 74. That's not 1. So you just have to go all the way down this list. Now these lists can get really, really long, but you know, the homework problems that I'm going to give you to work on, I'm definitely going to try to keep it, you know, like this being as big as it gets. Okay, they can get large, but I'm going to keep it relatively small, you know, so it's not just too awful for you to have to do this, but this is just what you have to do. So if you tested every single one of these numbers, you'd go 5, -5, 10, -10, 1/2, -1/2, 5/3. And I just now realized what I did. That's a 3 right there, and that's supposed to be a 2, isn't it? So 1 over 2, yes, I'm sorry, that's supposed to be a 2. I just now caught my mistake. So that should be 5 over 2. Okay, but go down that list, and what's going to happen on this one, you're not going to get any of these to end up equaling 0. Like, you need this right here to equal 0, and none of these are going to do that. So in this case, you would just say that you have no rational roots. Okay, so that would be your answer in this case, because none of them are going to give you 0 for this particular example. Okay, next one. Now this is actually doing the same thing, but they've changed the instructions, and you'll see the same thing happen as you go through your homework problems. One set of instructions will be like this last problem, and then you'll have another set of instructions you'll see these instructions, but it's wanting you to do the same thing, because see, it's wanting you to do your polynomial equal to 0. So that would be the same thing as saying equals 0. So you're going to have to do your P's and your Q's first. Okay, so for P, now we go to your constant term, which is -8. So that's going to be plus minus 1, plus minus 2, plus minus 4, plus minus 8. So this is all the numbers that'll go into 8. Okay, Q is going to be your leading coefficient. Well, here's my largest exponent. The number that I have in front right there is just a positive 1. So all I've got there is just plus minus 1. So when I make my list of P over Q, this is going to be easy, because it's just 1 over 1, 2 over 1, 4 over 1, and 8 over 1. Okay, so now if you start substituting in these values, so start with positive 1. So that means you would have 1 to the 3rd power minus 6 times 1 to the 2nd power plus 13 times 1 minus 8. This one's actually going to give you equal to 0. And that's what you're looking for. When they want you to find the rational roots, they're wanting to know the values that are going to cause this to equal 0. Okay, going down the list, because it can be more than one of them in the list that will work. Okay, so like if you were to try -1, you're going to get -28, so that's a no. And then you're going to try, you know, the positive 2, okay? And actually I didn't calculate what this value would be, but it ends up not being 0, I do know that. So if you were to go on down the list, the only one that's going to give you this answer of 0 is going to be at positive 1. So your answer, what is the rational root, is 1. So you could say x equal 1 is your answer for this one, okay? So like a while ago, there were no rational roots. Here you just have one of them. You can have 2 of them, okay? Actually, on this one, you could have as many as 3, because you remember what we've talked about before, your exponent telling you how many answers you're going to have. This one has 3 answers. It's just not all 3 of them have to be in this list. So that's why it's possible that there's none. There could just be 1. There could just be 2. Or it could be all 3. So that's going to vary from problem to problem. Okay, next. All right, here is a concept about your roots that you need to be aware of. I've been talking about rational roots, so this that I'm fixing to explain applies to irrational roots and imaginary roots. Of course, we've talked about imaginary numbers already, and of course these first 2 examples that I have here would represent imaginary numbers. Irrational are going to be like these 2. Irrational is where you're still going to have a radical sign, okay? Now, it says that your irrational and your imaginary roots will occur in conjugate pairs. First of all, if it's a pair, that means there's got to be 2 of them. So that's why on each line here you can see that I have 2 roots. These are 2 roots. Here's these 2 roots, these 2 roots, these 2 roots. That's because they're in pairs. Now, to be a conjugate...
Track needs to be dismissed at this time, please.
To have a conjugate, all that you do is simply change the sign that's in the middle. So like if I'm given this one that has the plus sign, then I just simply change that to a minus sign, okay? Now here, I just have one term, which is the imaginary term, so what you really have here is just an understood zero. So you've got 0 minus 4i, so you would have to go with 0 plus 4i, so that's why it goes from a negative to a positive. Same thing here. This would be the same thing as saying that you have 0 plus square root 5, so the conjugate would have to be 0 minus square root 5. So when you have just the one term, it looks like you're just doing the opposite. But when you have two terms, you're only going to change the sign that's in the middle. So down here, say I just changed the minus sign that's between these two to a plus sign. You don't change both terms. See, my -2 stay the same. Change the signs in the middle. Now, what you're going to be asked, like when you do your homework, is a question like this. It's going to say, find 2 additional roots. And this is where knowing what I just told you is going to give you the answer. Because this one is irrational, so this one's going to be an example of one that's irrational because it's still got the radical sign. Of course, this one is imaginary. So they have to happen in pairs. So if I know that 15 plus 3i is a root, then I am guaranteed that 15 minus square root 3 is. Okay, so just do that conjugate where you change the sign that's in the middle. Okay, so if I know that -7i is a root, and because of it being imaginary, I know that its conjugate has to be, so the conjugate of the -7i would be a +7i. So this would be the 2 additional roots. That's, I mean, it's not, you know, asking you to do anything more than just find 2 additional, and that's what we've done, knowing that they have to be in those pairs.